So we all know that in last class we studied what is the latent heat of fusion and as well as latent heat of vaporization. So if you come to the latent heat of fusion, so for example, if you have taken, if you want to melt the 1 kg ice, which is at 0 degrees Celsius, 1 kg of ice, which is at 0 degrees Celsius, if it wants to convert into liquid state at the same temperature. So what is the heat energy it has been taken, everybody? All of you? Yes, please. At the same temperature. What is the heat energy taken? We have been mentioned heat absorbed is equals to. Yes, please. Nobody knows. Yesterday we have written. Heat absorbed how much, Ra? It will take 3.35 into 10 power 5 joules of energy. What is the use of teaching then? Everybody leave it. No problem for me. So that is what it is. So this is the amount of heat energy it will take to convert 1 kg of ice from 0 degrees Celsius to 1 kg of liquid water at the same temperature. So this is only we used to called as latent heat of ice. So to melt the 1 kg of ice from 0 degrees Celsius to 1 kg of water at same 0 degrees temperature, this is the heat required. So this is only we used to called as, what used to call, guys? Latent heat of fusion or latent heat of vaporization? Latent heat of fusion. Same way, you want to convert 1 kg of water at which is at what temperature, Nivedan? 1 kg of water at what temperature? At 100 degrees Celsius. If you want to convert it into 1 kg of steam at same 100 degrees Celsius, then what is the heat absorbed again? Everybody. Yes, please. Heat absorbed by the water. How much, Ram? 6 into 10 to the power of 5 joules. So that is why if you touch the hot water or if the steam is touch your skin, which will be very dangerous, it will condense everyone, which will be damage our skin, severe burnings, either steam or it is hot water. Everybody? Steam. So the same temperature, if you take at 100 degrees Celsius, if you pour the water on your skin, compared to the water at the same 100 degrees Celsius, if you contact with the steam, the burning will be more compared with the boiling water, because at the same 100 degrees Celsius, steam is having extremely high energy. So this is only we used to call as, what is to call, everybody? Latent heat of, yes please. Latent heat of vaporization. So like this, for different substances, they are having different amount of heat absorption at converting from solid state to liquid state. So which will takes place at particular temperature or any temperature, boiling, melting. It will takes place at particular temperature. Yes or no, guys? All of you? And same way, liquid state to gaseous state also, it will also will takes place at particular temperature. So always at the temperature only, either the solid material will be converting into liquid and as well as liquid will be converting into gases. Now, if you observe, if you want to convert solid to liquid or liquid to gas, we need to heat it or we need to cool it. Everybody? We need to heat or we need to cool. If the silence is not the solution, if you are silent, not necessary to attend the classes also. I am very, very particular about anybody. Either 10th or 9th, same thing for me. I'll just throw out. It's necessary, not necessary to attend if you're not showing interest. So you can see here, if you want to convert from solid state to liquid state, this is our textbook only. That is the reason I will tell you to read always. So if you want to convert solid state to liquid state, we want to what? We want to heat it or we want to cool it, everybody? We want to heat it.
Heating.
If you want to convert liquid state to gaseous state, now heat is again we have to heat it or we have to cool it, everybody?
Heating.
Heat it. Now reverse process. I want to convert from gaseous state to liquid state. What I have to do? I have to cool it. Same
Cooling.
liquid state to solid state. Again, what I have to do? Everybody, cool it.
Cooling.
For example, let me take now, all of you observe very carefully what we studied. let me take. Now 1 kg of ice, if I take an understanding at 0 degrees Celsius. So you can see it is taking 3.35. How much amount of energy, everybody? 3.35 joules of energy to convert into 1 kg of water. 1 kg of water at the same 0 degrees Celsius. Is it right or wrong, everybody? Yes or no? It is heat absorbed. Yes, Nivedan? It is heat absorbed. Heat is absorbing, heat is increasing. Now, I will do reverse. Now, I want to convert 1 kg of water from 0 degrees Celsius to, I want to convert into 1 kg of ice to at the same 0 degrees Celsius. Now, heat will absorb or heat will release. Here, heat is absorbing. Heat absorbed is this much. Now, here heat will release or heat will absorb, guys. Anybody's? It is reverse process. So that heat will absorb or heat will release. Everybody.
Heat released.
Heat released. Now, how much heat is released? Yes, girls. Shivani, Agalya, how much heat is released? That is what my question. For example, if you are converting from X to Y, you are spending 100 rupees. Like, for example, I'm saying. So, from making X to Y, it is taking, for example, 1 joule of energy. Now, reverse, if Y to X also, again, it will release how much? It is absorbing 1 joule of energy. And if it is reverse process, then how much amount of energy is released? Same amount of energy will be released. Is it right or no? All of you? Yes, Mr. Lingesh, very good. So, whatever the energy taken to convert 1 kg of ice to 1 kg of water, then the same energy will release if it is converting from 1 kg of water to 1 kg of ice. Is it okay? Is it okay, guys? Everybody clear? Understand? So, what is the energy is released when it is reverse process? All of you. 3.35 into 10 power 5 joules of energy will be released. Understand? Same way, if I am converting from steam to water, anybody can tell me what is the energy will release? Yes, Mr. Nivedan, Lingesh. Steam to water, how much amount of energy is released? 22.6 into 10 power 5 joules of energy. That is why when it will touch our skin, it will condenses very fastly. So more energy will release or less energy will release? Everybody. More energy, which energy, how much energy it will give out? It will give out extremely high energy. That is what 22.6 into 10 power 5 joules. That is the reason the steam will burns. Steam will causes severe burn as compared to the boiling water. Is it okay, guys? Please respond, guys. All of you. Yes? Understood or not, Amma? That is what. So, you have to read it everything, including the here, each and everything. Today's work I am giving you. Your today's reading work till page number 7, including this activity. See, this activity, conversion of ice to water and conversion of water to water vapor. Same way, this activity, both. One activity converting from ice to water, another one from water to gaseous state. So both same thing. Here we are getting latent heat of fusion or latent heat of vaporization. Everybody converting from ice to water, latent heat of fusion, latent heat of fusion will come. Okay, same way here, latent heat of what will come? Everybody,
Vaporization.
latent heat of vaporization.
Vaporization.
So, the activities. So once the temperature reaches to here, what is the temperature? Can you tell me here now? The red mark, which is equals to how much degrees Celsius? 100 degrees Celsius.
100 degrees Celsius.
Yeah, the temperature converting ice to water. Then what is the temperature here? Everybody, 0 degree. 0 degree. That is what you have to remember. Okay. So this is the temperatures you have to remember. So now by tomorrow's what is your work is till here. All of you should read each and everything. You can see here they mentioned perfectly. The melting point of a solid, it is an indication of the strength of the force of attraction between its particles. We have studied or not? Importance of significance of melting point. Yes, Mr. Everybody? Significance of
Yes, sir.
melting point. Yes or no? That is the importance. Each and every statement from your book, I will turn into a concept. So that is what I am saying it. Now next they are asking, can you define the latent heat of vaporization? Yes. they are not giving the definition. But I taught you or not yesterday? Yes or no? All of you? Yes. So your work is by tomorrow's, you have to read till here. All of you remember. Till here you have to read it. Please note it. Page number 7 till this activity. Of course, this activity is different. Till this activity, everybody should read it. Is it okay, guys? All of you? Yes. Each and every word you have
Okay,
to,
sir.
and you have to report me in today's before evening. You have to report it. Okay. Now, in our today's class, we are going with a reverse process. That is what they are saying here. Vice versa, without changing into, that is what a liquid state we all know, directly gas to solid and solid to gas. What is that? What is the process we used to call as without forming the liquid?
Sublimation.
Sublimation.
So both we can say sublimation, or down we can say what? Instead of sublimation, directly gas to solid,
Deposition.
we used to call as deposition. So let us see. In our today's class, we are going to study first gas to liquid reverse process, and then liquid to solid, and then directly solid to gas, and same way gas to solid. Shall we start, everybody? Are you all ready? Everyone? So that is
Sir.
what you have to remember it. Now, so all of you keep reading. We all know converting from gas to liquid, we used to call it as condensation, or we used to call it as liquefaction. What we used to call, everybody? Condensation, or we used to call it as liquefaction.
Liquid.
So third process, condensation. Now tell me anyone, Mr. Kishore, I want to answer from you. Condensation or liquefaction means, so we have to lowering the temperature, or we have to increase the temperature? Anybody? We have to increase or decrease the temperature, guys? Alvin? Condensation means reverse process. So we have to decrease the temperature, or we have to increase the temperature, guys?
Decrease temperature.
Increase the temperature.
Understanding? That is what. So write it now. Okay. So make it everybody. Now. So let us see in our daily life. All of you observe. Now, if you stand in front of the mirror, how many of you are having mirror in your home? Everybody? Yes, do you have mirror? All of you?
Yes, sir.
Now not, of course, mainly in winter season, you can see, if you just trying to blowing the air in the mirror, have you noticed that mirror water droplets will form, or it will become like a hazy mirror? Have you noticed it? Have you all experienced it? All of you? You experience it or not? You have to say only, then only I'll say that. If you blow the air on the mirror, have you noticed it like that? You can see that mirror will become into hazy mirror. Yes or no? All of you?
Yes, sir.
Yes. Have you all experienced it or not? Again, you will wipe it. Yes or no? Your car also you can notice it. When you are driving in a winter season,
Yes, sir.
yeah, it will become like a hazy mirror. And again, your father will turn on the wiper and it will clear it everything. Yes or no, guys? Your father or mother, whoever driving, so they will they will turn on the wiper so that it will be clean out. Yes or no, guys?
Yes, sir.
Yes, that
Yes,
is
sir.
what. So if you notice it, in winter season, you can see morning time you go into the any kind of leaves or any kind of agricultural land and all. Most of the leaves, you will notice the water droplets. Have you all experienced it? Water droplets will be there on the leaves of the plant. Yes or no, guys? Yes, please. Have you noticed or not? That is what we
Yes, sir.
dew. Basically, we used to call that as a dew. That is what we are noticing, the water droplets on the leaves. Or we used to call it as, that is only we used to call it as what? Everybody? We used to call it as condensation. Understand? So whenever you can see like this mirror, or we can see in the winter season, like water droplets are forming on the leaves and all, you can see it happens due to the conversion of water vapor into liquid, whatever it is. If you blow the air into the mirror, immediately it will turn into hazy mirror. Yes, Mr. Sam, have you experienced it? Nivedan, Lingesh, that is. So this is all because the reason is behind, sir, why, sir, what is behind the conversion? So how it is turning into hazy? Because due to the conversion of what, guys? All of you? Due to the conversion of water vapor into what? All of you? Water vapor into water. That is what we used to
Water.
call as water, which we used to call as liquid. Means it is converting from gas state to what state? All of you? It is converting from gas state to
Liquid state.
So this conversion of water vapor into water into water, only we used to call as what is to call, guys? Yes, please. What is to call? What is the phenomena name called as? Conversion of water vapor into water. What is to call?
Condensation.
Condensation. Okay. Into water is called condensation. Okay, understand everybody? Shivani, Agalya, Hasini, that is what.
Yes,
Okay.
sir.
Now, this water vapor, it will getting converting into what? Liquid. So, from where these water vapors are coming? Anybody can tell me? So, the water is coming from like, which is depositing on the plant leaves or in our car and all. Where it is coming? Anybody? For example, let me take, if I am blowing the air, it is turning into hazy picture. Then that water vapor coming from where, guys? Atmosphere or from your stomach? Where it is coming? Any one of you? I am blowing the air. Where it is coming? Anyone? Water vapor is coming from where? Yenara. Our respiratory air contains what? Any one of you? And have you noticed it? In winter season, from our mouth, we used to notice that like smoke like thing is coming. Have you experienced it? Everybody? At least anyone, nobody is experienced that. This is very, very.
Yes, sir.
Yes.
Yes,
That
sir.
is what. So you see that even close-up ad. Have you noticed that close-up ad that one boy will come and blow the air in the glass so that it will turns into hazy and then he will write something on it. Have you noticed it or not? Yes. So the water
Yes, sir.
which is coming, which is condensing on the glass or the mirror, which is during coming from our stomach because of respiration process. So respiration, what is the products will come? Everybody, two products will come. What is it? Anyone can tell? Respiration, human respiration. Sir, NSR, chemistry, biology were teaching.
Oxygen, carbon dioxide.
Sanjay, how Sanjay? Respiration, what is the products will come? Oxygen will take out, inhaling will take oxygen. Exhaling, what will come?
Carbon dioxide.
Carbon dioxide.
Yeah, carbon dioxide. So respiration, the out products are like carbon dioxide and as well as water vapor. Okay, so this water vapor only, when we blow the air into the glasswares or any kind of mirror, it will immediately condense into what? Everybody? It will condense into liquid. That is what it will turns into a liquid state. Hazy mirror. Mr. Lingesh is saying he is experienced in hilly area. Yes, Mr. Lingesh. Have you experienced it? I think in Ooty you experienced it. Is it correct?
Yes, sir.
Okay, very good. So that is only ways to call it as condensation. Now, let us see, let us make, of course, I have told you the definition for condensation of water, but let us write the common definition of condensation. So to condense, we have to lowering the temperature or we have to increase the temperature, Mr. Sanjay?
Increase the temperature.
Increase the temperature. Yes, everybody? Sam? We have to decrease the temperature. Write the definition, all of you. The process, for perfect definition, this is the definition for condensation. The process in which can you able to see my screen? All of you, very small screen, huh?
Yes, sir.
1 minute. Is it okay now? Is something happened? Yeah, okay. Shall we start now, everybody? Can you hear me?
Yes, sir.
That is what, right? The
Yes,
definition.
sir.
The process in which a gaseous state is converting into a gaseous state is converted into liquid state by lowering down, it's what? Everybody, temperature or pressure? By lowering down its
Temperature.
temperature. That is only called as condensation. Is it okay, guys? Yes. So in winter season and all, what you are seeing that you can see that everything, the condensation point will happen, the leaves and all, what you are seeing, the water droplets and all, that is only we used to called as, what is that called as? All of you, we used to known as dew.
Dew.
Okay, so that is what. So let us see how it will be happening and how it will make it. So have you ever observed that the steam is cooled to change it into liquid water? Anytime anyone observed it? All of you? Yeah, I will notice in our life, daily life also. Yes. Have you all experienced, for example, today afternoon, your mother is cooking the rice and she kept the rice, not during the cooking time. Once she has been kept the rice, not only rice, anything, chicken curry or mutton curry or any kind of gravy, whatever it is, if she has been prepared and kept separately on the dining table or in our kitchen, okay, so definitely she will cover with some kind of a lid. Yes or no, Mr. Lingesh? Everybody, Kishore? Now, so today afternoon or now breakfast time, once as your mother, for example, today is your breakfast is a idli. So now observe this. After the cooking the breakfast, you will put it in the hot box. Yes or no, ma? Yes, please.
Yes, sir.
Hot box you will put it so that you can go and you can serve it and you can have it. Now, so hot box in the sense of when the idli is kept inside, definitely it is having a some water vapor, which is in what state? Water vapor I am saying. So what state it is? It will be in a yes, please. Gaseous state. Now, like when the air, hot air is coming and touching the mirror, it will from our mouth, it is condensing into what state? Everybody, it is condensing into liquid state. Yes or
Liquid
no?
state.
Same way, this hot water vapor, which is present in these idlis and all, if it is actually when you close the lid, this hot air will go and will touch this lid so that the lid will absorb the temperature so that all the water vapor will be condensed at this plate. So that is why you can see as soon as if you remove the lid, you can see plenty of water will fall down. Have you all experienced it? Anybody, girls, boys, Alfin?
Yes, sir.
Yes or no? So that is what. So when hot water with vapor closed with some lead, some Lingesh is saying, after some time when we open the lid, in that the lid some water droplets will be there. Of course, the Sanjay, Lingesh, the same thing. Not only hot water, Lingesh, any curry or any tiffin you can see, if you just closed with the lid, then after some time you can see the lid is fully filled with the water droplets. Yes or no, guys? Everybody? How it is happening? Because when you close inside if you kept a hot food inside the bowl and if you close it, then the hot water vapor which is present in it, it will go and will hit the lid and this lid will take out the temperature, everything. So temperature is lowering. If the temperature is lowering means then this gas will be condensed back into what? Everybody. The gas will be condensing back into liquid. So that liquid will stick to the surface of the lid. Is it okay? Everybody, Kishore, today you have to observe, everybody. Will you observe or not? Already you might be observed it. Is it correct? Yes? Yeah, everybody.
Yes, sir.
That is the reason. So we can make it also. So let us see. We know that on boiling, for example, if you want to observe in our daily life also, today's, you go to the kitchen. So whatever I will say, you follow and 100% you people can be getting back. Now, how to make it means this process. So let me see, you all might be having a tea kettle or water kettle. Yes or no, guys? If you go to shops and all, so the tea kettle will be like this. Is it, you might be all notice it also. So tea kettle, observe everybody, I'll draw it. So you might be having the tea kettle like this. Is it as guys? Like or a small mother in the mother area? Yes, all of you? Tea kettles. Yes. So pour the water inside if you're having in your home or any kind of beaker also, no issues. So if you want to test it, but with your presence of your mother only. So just pour the water inside and keep on boiling. So why I am taking this one? So that the steam only come from the small opening. Yes or no, Nivedan? So that we can see the experiment very properly. Okay. So that is the reason. Okay, Amma. Everybody clear, Amma? Yes. So start heating it, more heating. So you start heating. Then you can see After some time, you can notice that like smoke like thing is coming from this. Actually, what is that actually? Anybody can tell me? That is only what is steam. Yes, steam or we used to call as. What is that called as? All of you. Vapor. Okay. So steam is coming outside now here. Now, if all people knows the dosa pan theriyuma, everybody. Yes.
Yes, sir.
And also, Kishore is saying, have you all noticed it when your sunglasses or you are putting the spectacles, just blow the air into your specs, they'll become into a hazy. Is it right or wrong? Verified?
Yes, sir.
Yes or no? Yes, that is the reason. So this is all everything what condensation only. Now take dosa pan with your mother's help. Okay, if you are having. So now dosa pan, what you will do? Of course, this is the summer season. I think most of our Indian kitchens we are having a full of ice cubes inside the home. Is it right or wrong? Everybody, all of you. Yes. So now, if the steam is coming like this, take the dosa pan, okay, and one side of the dosa pan, you just put inside. Inside, you put the ice cubes. What you have to put, guys? Ice. Respond, Ra. Inside that, you put the ice and you handle with the care. Now, let me take these fumes are till here coming. So these fumes are coming and I am blowing. You just adjust it and keep it here. I am drawing it. So the fumes are coming and they are touching the bottom surface of this dosa pan. Is it okay, Ma? Shivani? They're touching the bottom surface of the dosa pan. Now you can see, of course, the ice is up. So that ice, what it will do, guys? It will absorb the heat energy from this hot fumes and the ice will melt into what? Slowly ice will melt
Water.
into water. But if you see, as the temperature is taken out from this water vapor, as the temperature is taken out from this vapor, this all the water will be condenses at the bottom of the dosa pan. Is it right or wrong, guys? Bottom of the dosa pan. Now, if you want, you can keep the beaker here. You can see this entire condensing water. You can notice it drop wise, it will fall into this container. Okay, guys, everybody. Yes, Shivani, Agalya. So you can present it.
Yes, sir.
So if you are having the facilities, definitely I will show you. So take the dosa pan and handle with the care. If you are curious, your parents are supportive, you can just see for 1 or 2 minutes. At least you can condense 1 or 2 drops of water. But don't think that water is condensing means, is it the water is coming from the ice or gas is condensing? Anybody? Gas is condensing. Understanding? The what ice is present upper part of the pan. So that water won't be come down. Is it okay, guys? Everybody? Understand all of you? Yes? So this is only called as, what we used to call, see here. Now we are converting here from liquid state to gaseous state first. What is that called as? Anybody can call? What is that called as? Vaporization. You can say boiling. Now, from here we are converting gaseous state to liquid state. So that it is called as what? All of you. It is condensation. So simply I can say vaporization is just opposite to the condensation. Yes or no? Everybody? Mr. Nivedan? Yes. So I can say condensation is the what, guys? Ma, please mute yourself, Ma. Lakshana. So condensation is a what, guys? Reverse process of what? Reverse process of evaporation. Condensation is the reverse phenomena. Write it. Reverse phenomena. Ma, what is this, Ma? Disturbance for others. Please be careful. Reverse phenomena of vaporization. Reverse phenomena of vaporization, as vaporization requires high temperatures or low temperatures, Mr. Sam? As vaporization requires high temperatures or low temperatures, guys?
High temperature.
That is what. Vaporization requires high temperature. So that is why converting from solid liquid to gas, we are heating or we are cooling? We are heating. And liquid to gas, what we are doing? We are cooling. That is what. Okay. As vaporization requires high temperature, Whereas, Sanjay, understanding Ra? Whereas condensation requires what, guys? All of you. Lowering the temperature or increasing the temperature? Condensation required. Lowering of temperature. Okay, Kishore, Sangamitrai, that is what you have to remember. This is the experiment you can conduct to carry out the what? To carry out the condensation process. Anybody having any doubt, you can ask me. Clear, guys? All of you understood? Yes, please. That is what. Abhirami, Agalya, Alfin. Okay.
Yes, sir.
You also no response at all. Alfin, Asini also. That is what it is. Okay, complete it fastly. Who else is absent today? Mr. Mari, Mr. Pranav, Gokul Raj. Next, who else is missing? Okay. Make it quick now. Any doubt, guys? Ask me. Clear? So this is what is condensation. Now, liquid state to gaseous, liquid to solid state. What we used to call? Everybody? Liquid to solid state. What we used to call? Opposite to the melting. What is that called as, guys?
Freezing.
Solid. Yes. Freezing. We used to call. So what is the freezing point of water? Anybody can tell? Freezing point of water. Please.
0 degrees Celsius.
0 degree
0 degree
Celsius.
Celsius or is equals to how much, Agalya?
273 Kelvin.
15 Kelvin. That is the melting point of water, and as well as next one is what? FP, freezing point of water also. Clear? That is what. Now, before going to freezing, actually, we should break it here. So can you tell me example if I take, what is the boiling point of water? Boiling point of water. Everybody?
100 degrees Celsius.
100
degree
degrees
100
Celsius.
Celsius, or we can say 373.15 Kelvin. Is it yes or no? All of you? And same
sir.
way, condensation point, Cp of water. What is the condensation point of water? Which is also equals to how much? 100 degrees Celsius or 373.15 K. So boiling point above 100 degrees Celsius. So, condensation point, what is that, guys? Everybody, below 100 degrees Celsius. So that is why we can say for every substance, boiling point is equals to what? Everybody, boiling point is equals to condensation point. So whatever the boiling point, the same condensation point. At the temperature, more than that, it will converting into gaseous state. Less than that, it will converting into what state? Everybody, it will converting into liquid state. Clear? Any doubt? Anybody can ask me. So for any substance, boiling point of a substance is equals to what substance, guys? Condensation point. Okay, guys? Any doubt? Ask me. Understood? All of you?
Yes, sir.
Okay. Next. So next, liquid to solid. That is only wish to say. So D process number D. That is what? Freezing. Okay. So freezing means again what? Lowering the temperature or increasing the temperature? Anyone? Freezing.
Lowering the temperature.
Lowering the temperature because it's a reverse process. Okay. So freezing means change it from liquid state into what state, guys? Everybody.
Solid.
Solid.
Solid state.
Solid state.
Yeah. Change of liquid. Change of liquid state into what state? Everybody? Into
Solid.
solid state. So that is only called as freezing. So how? If the temperature is decreasing or temperature is increasing? Everybody?
Decreasing.
Temperature is decreasing. So if you are further decreasing the temperature continuously, so definitely it will be converting into what? It will be converting into solid state. Write it. If the temperature of the liquid is lower, all of you write, if the temperature, Mr. Lingesh Puriyamara, temperature of a liquid is lowered continuously, then it gets converted It gets converted into what state, guys? All of you. What state, Ra?
Solid state.
Solid state. So that is only ways to called as what? What is this process called as? Converting liquid state to solid?
Freezing.
Freezing.
That's freezing. So okay. So let her write the definition. All of you. So write everybody. Freezing point. So this process only ways to called as what? Everybody? Converting. Freezing. Freezing means converting from what to what?
Liquid to solid.
Liquid state to solid state.
Changing of liquid state into the solid state. How? By lowering the temperature. So at a particular temperature only liquid will converting into solid. That point only we to called as. What point we to called? Everybody.
Freezing point.
Freezing
We to
point.
called as freezing point. Okay. So write the definition. The temperature at which liquid gets converted into solid. Liquid gets converted into solid, but by the time somebody is constant. Can you tell me, Nivedan, fastly?
Temperature.
Pressure.
At what pressure?
Atmospheric.
At atmospheric pressure. That is what is expected. Atmospheric pressure is called as what? Everybody? Is called freezing point. So what is the freezing point of water? Anybody can tell? Yes, please. Example. Freezing point of water. Yes, water freezes at
0 degrees Celsius.
0.15 Kelvin or 0 degrees Celsius. Is it okay, guys? So now different substances having different freezing point or same freezing point? Everybody? Yes,
Different.
different freezing point.